Okay, we are talking about completing the square today and why we care. Make sure you have a piece of paper handy, a pencil to take notes. We're going to do our learning on video today. And remember, you can always pause and rewind if you choose. So let's just review completing the square before we talk about why we care about it. So let's take a problem. Let's say we have x squared plus 11x. Ooh, let's not do 11. That's a little more challenging. Let's do 12. X squared plus 12x plus 3 is equal to 0. Now, what we're saying when we're solving this equation is we're saying what values of x would make this statement true. Another way to think about that is if we were graphing this parabola, where would it cross the x-axis? So I notice, first of all, it's not factorable. I can't factor it. So I'm going to move on to completing the square as the method of choice. So what I'm going to do is I'm going to think about this guy as the square. I'm going to try and create a perfect square trinomial. So I'm going to just move 3 over to the other side. I don't want to deal with it. So I get x squared plus 12x plus some number will make that be a trinomial square, and that's going to be equal to -3 plus that same number, because we know when we add something to one side of the equation, we also have to add it to the other side. Now, I like to go down a step and think about, well, what would that trinomial square be? What should go right here? Well, the way we figure out what should go right there is we take our middle term and we divide it by 2. 12 divided by 2, 6. Then, in order to go back up to this blank, we have to think about what 6 squared is. 6 squared, 36. I'm going to add 36 here, and I get 33. So I have a trinomial square, it's equal to 33. And then I can just square root both sides. I get x plus 6 is equal to plus or minus the square root of 33. This plus or minus, super important, because remember, many parabolas, some might say most, are going to have 2 roots. 2 possible answers that make it work. Subtract 6 from both sides and get x equals -6 plus or minus the square root of 33. My apologies. Now you may be thinking, oh, but can I reduce 33? Can I reduce that? Well, I am glad that you asked that question. If we think about the factors of 33, the factors of 33 are 3 and 11. So this is really the same as the square root of 3 times 11, or the square root of 3 times the square root of 11. 3 and 11 are both prime. They don't have perfect square factors, so this here is actually as simple as it gets. I suppose you could write it as 2 separate things, -6 plus the square root of 33, and -6 minus the square root of 33, really showing that there are indeed 2 solutions here. Either one of those box answers is acceptable. Okay, so my hope is that we have this piece, we understand this piece. Now, there's another piece that we talked about on Friday, which you may recall, which is graphing using vertex form. Okay, so let's say we had an equation, I don't know, y equals x minus 3 squared plus 1. Now, this equation is in vertex form. What it tells us, and if you want to do like a sidebar, vertex form is this: y equals a times the quantity x minus h squared plus k, where hk is the vertex, and a is a. A controls stretch and shrink, and if it's reflected across the axis. So if I gave you this, you could tell me quite easily, oh, well, the vertex is negative 3. No. The vertex is 3, 1. So if you were, oh, and what is A? A, in this case, is 1. It's not shown. It's just right there. So if we wanted to graph this little baby, we would draw our XY coordinate plane. And notice I would go over 3 and up 1. That would be my vertex. And then I can follow the parabola pattern. You guys remember the parabola pattern of A? Over 1, up 1. Over 2, up 4. Over 3, up 9. And so on and so forth. And then you just draw your parabola curve. Make sure it looks like a parabola. Make sure you have the arrows on there. And you have your parabola. So it makes graphing incredibly easy. And just kind of an interesting note here, this parabola does not cross the x-axis. More on that another day. So we're going to take this idea and combine it with this idea. So wouldn't it be so nice if we could just really quickly and easily get a parabola into vertex form? Well, in comes completing the square. So let's say we have an example. Let's say we have y, we'll call this example 1. Y equals x squared plus, I don't know, 3x minus 2. Now, this parabola is not factorable, so it's not going to have nice, pretty, clean, easy x-intercepts. But we can take the idea of completing the square so we can easily graph this, finding the vertex. So let's do that. Now, see this negative 2 right here? That's not part of our, we don't really want it. So what we want to do is just really focus on this piece. So actually, I'm going to change this. It's not going to be 3 because that makes things just kind of grumpy, and we don't want to be grumpy on our first example. So let's make that 4. Okay, so see this 2, I'm just like, I don't want to deal with it. So what I'm going to do is I'm going to add 2 to both sides of my equation. So now I have y plus 2, it's just over on the other side, I don't have to worry about it, is equal to, actually I'm going to just leave a little bit of blank there. You'll find out why in a second. X squared plus 4x plus blank. I'm going to complete the square to get it in that nice vertex form. To help me complete the square, I'm going to go down a step, x plus blank squared. Well, what should go in the blank? I'm going to take this number, I'm going to divide it by 2. I'm going to get 2. I'm going to take this number and I'm going to square it. 2 squared is 4. And since I've added 4 to this side of the equation, I must also add 4 to this side just to keep it balanced. Right? So now I get y plus 6 is equal to x plus 2 squared. Now I can subtract the 6 back over and I get y equals x plus 2 squared minus 6. Ta-da! Now we have our formula or our equation in vertex form. So we're really working on going from standard form to vertex form. I'm going to write that right out here. One of the reasons why we care about completing the square is that it makes it easy to go from standard form to vertex form. Now, if we were to look at this highlighted equation and I asked you what the vertex of that parabola is, hopefully you would tell me it was -2, -6. We know that because this plus 2 can really act like a minus negative 2, right? When we subtract a negative, we essentially add it. So our vertex is negative 2, negative 6. All right, we're going to do another example. This time, I want you to try this one on your own. Pause the video and then come back for the explanation. So let's say we have y equals, we'll try another, x squared minus 10x plus 4. Okay, so pause the video and try to complete the square. Okay, we're back. And if you're back, that means you have actually attempted this equation. And let's see, here's how we do it. I really care about that trinomial. That's what I want to make be my trinomial. So I'm going to subtract 4. I'm just going to get rid of that number, move it over to the other side, just so I don't have to worry about it for the moment. And if I like, I can know that I'm going to add another number just to keep all things fair and equal. So I'll have y minus 4 plus blank is equal to x squared minus 10x plus blank. I'm going to step down a level. So x, and now since this is minus some number squared, in order to go from 10 down to this level, I divide by 2. Negative 10 divided by 2 is negative 5. And then in order to go back up to this level, I square it. Negative 5 squared is 25. Since I added 25 to this side of the equation, I must also add 25 to that side. And when I add 25 to that side, I get y plus 21. From there, if I want to solve for y, I'm going to subtract 21 from both sides of my equation, and I get y equals x minus 5 squared minus 21. If I were to ask you now, what is the vertex? You would say to me, oh, Ms. Miller, that's easy. It is 5, negative 21. Ta-da, ta-da. Okay, let's try another example. This time we're going to try one where a is not 1. Okay, let's see here. Example 3. Let's say we have y equals 2 x squared plus 24x minus 18. Okay. Let's see, what should we do first here? Well, we are going to add 18 to both sides. Remember, this is the trinomial that we want to deal with. So we're going to move 18 over. We're just not going to deal with it right away. Y plus 18 plus some number, we're not sure what that's going to be yet, is equal to 2x squared plus 24x. Now our next step, before when we were solving, we would just divide out that 2. But this time we're going to factor it out, because remember, our general form, if we think about what our general form is, it's going to be, I'll write it right here, y equals a times the quantity x minus h squared plus k. So that's what we're aiming to repeat. So we're going to factor out the 2 here and get x squared plus 12x. Now we know there's going to be some kind of number that we're going to add to make that a perfect square trinomial. So I'm going to just add that blank there. Now if I have a 2, if I go down a step, this is going to be x plus blank squared. So what number goes in this blank? And what number goes in that blank? And that blank? And that blank? Ah! Blankety blank, blank, blank. So to step down from 12, I divide it by 2, I get 6. Square it, and I get 36. Notice that this is equivalent to that. They're both being multiplied by 2. But I didn't just add 36 to this side of the equation. I added 36 times 2, which is actually 72. 36 times 2 is 72. And since I added 72 here, I must also add it here. 72. Well, what is 72 plus 18? That's going to be 90. So I have y plus 90 equals 2 times the quantity x plus 6 squared. Now I'm going to subtract 90 from both sides. My goodness. And I get y equals 2 times x plus 6 squared minus 90. Now, if I were to ask you what a, h, and k were, a equals, h equals, and k equals, what would you tell me? Hopefully you would tell me that a was 2, h was negative 6, and k was negative 90. There we go. There's our stuff. Shall we try one more example? This one where a is not 1, and you try it first on your own? Sure, let's do it. Okay, example 4, our final example. Let's say we have y equals 3x squared plus 12x minus 25. Okay, so we're overusing 12. Let's not use 12. Let's use 18. Okay, so we are going to, you're writing this down. You were pausing the video. You were doing this problem, and at the end, you're going to tell me what a, h, and k equal. Okay, we're back. We're back, and that means you have completed the square. You have determined what a, h, and k are. I'm going to take you through the steps. First, add 25. You get y plus 25 is equal to 3x squared plus 18x. You then factor out the 3. Oh, it was so convenient of me that I made those both factorable by 3. You're welcome, guys. Also, maybe put a little blank there. Maybe put a little blank there. Okay, so I factor out the 3 and I get x squared plus 6x plus blank. We don't know. Then I think I go down one further step. This is going to be x plus blank squared, right? So we have to determine what number goes here, 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 and here. Let's see. I'm going to start down at the very bottom because this 6, I can divide it by 2 and get 3. 3 squared is 9, so that takes me up to that level. But 9, I'm not really adding 9 to this side of the equation. I'm adding 9 times 3. 9 times 3, 27, which means I need to add 27 over here, which means I get y plus 52. So I'm going to subtract 52 from both sides of my equation, and I get y equals 3 times x plus 3 squared minus 52. Now, here's where you find a, h, and k. Let's see, did you write 3, negative 3, and negative 52? I hope so. Okay, more in the next video.